simplify, correct? Simplify. There's easy ways and hard ways to do this. Now everybody watch, because maybe you'll choose to simplify this in a different fashion when you get to the test than what you did on your quiz. First of all, isn't this one, we could rewrite it as a radical, but that's harder than it needs to be. Isn't this, when you multiply the same base, you add your exponents? So this is base 5, and then 3 halves plus 1 half. Now you can do it in your calculator, or you could just know, because we have a common denominator with adding fractions, then we can add straight across, which is 4 halves. What is 4 over 2? 2? So 5 squared, which is 25. How many of you said I'm going to rewrite it as a radical and then you did it? That's completely right. How many of you did it that way and got it the right answer? Anybody? Awesome. Yeah, there's 2 different ways to do it. Not one is more correct than the other. Both are correct. Now, number 8, notice something here. On this one, we could think of it a few different ways. We could say, aren't we raising that and that to the 1/3 power? So we could do that. I just personally chose to say, okay, I'm going to rewrite rational exponents as a radical in this one. So this is the cube root, correct, of negative 8y to the 9th, and then all to the 1st. So that's the cube root of negative 8y to the 9th. What's the cube root of negative 8? Negative 2. How many groups of 3 is there in 9? 3, right? 9 divided by 3. So we get negative 2y cubed. Do you see how easy that one was? Or you could have done raise the power to a power and you multiply. Negative 8 to the 1/3, and y raise the power to a power, you multiply. That's 9 over 3, which is 3. So then the cube root of negative 8 is negative 2. We got there 2 different ways. Does everybody see? Which way is easier for you? Just curious. That way or that way? First way? Some of you like the second one. I'm just interested on which one you like better. Like I said, not one is more correct than the other. Both are correct. Okay, number 9. A lot of people got freaked out by this one. But remember, just because if we have all of this stuff raised to the 4th, that's the same thing as saying this. Square root of 9xy squared to the 4th in here. Does everybody know that that's the same thing? Okay, so this is how you could think of it. You could think of it like this. If there is 9x and y squared all to the 4th, isn't that 9 to the 4th? X to the 4th, raise the power to a power NU. So we have y to the 8th. Now 9 to the 4th is 9 times 9 times 9 times 9. We're pulling our groups to 2. So we have an 81, correct? Yeah. 4 divided by 2 is? 4 divided by 2 is 2, correct? And then 8 divided by 2 is 4. So that's one way of doing it. Another way of doing it, which is just as easy, if not easier, is to say, I know that this stuff is raised to the 1/2 power. Same thing as square root, correct? Raise the power to a power NU. What's 4 times a half? 2. 4 times a half. So that's 9xy squared to the 2nd power. So now we have 9 squared x squared y to the 4th. 9 squared is 81. X squared y to the 4th. Do you see how I got there 2 different ways, but still correct? You choose the correct way. Choose whatever way you like best. Hey, I don't know how many people got number 10 wrong, but a lot did, and it's super easy. Raise the power. Well, first of all, notice something. Inside our parentheses, there's not the same base. Raise the power to a power, and you multiply the powers. What's 1/6 times negative 18? If you don't know, type it into your calculator. You get negative 3. So we have x to the negative 3. 1/3 raise the power to a power, you multiply, you get y to the negative 6. So then you'd say to yourself, those are not acceptable answers because we have a negative exponent. Flip that over a fraction. Looks like I need to flip that too. So that's x positive 3, y positive 6, correct? Left on top was a 1 then. So hopefully some of you are thinking in your heads, wow, I made this harder than it needed to be. It was actually pretty easy. Number 12. Go to number 12. This one is literally the second easiest one on there, and most of you missed it. Everybody look up here. When you divide the same base, what do you do with your exponents? Subtract them. Are we all paying attention? If we go this grandma slow because nobody will talk to me and interact with me, then this is going to be a boring and slow lesson. When you divide the same base, you subtract your exponents. You always subtract top from bottom. So isn't that x to the 4 minus negative 1? That's just in here, correct? So So that's x to the fifth. So we have x to the fifth. We simplified inside. Raised to the negative 1/5. Raise the power to a power NU. What's 5 times negative a fifth? 5 times negative 1/5. Guys, 5 times negative 1/5. Sorry, that's 1. So that's negative 1, guys. If you can't do that, just do it in your calculator. Negative 1. Is that answer acceptable? Nope. We flip it over a fraction. So won't our answer be 1/x? That was such an easy one. But I do know that it was a long time since we've seen ones like that. So don't get to the test and mess it up. So now that we've gone over 1 like 14, you should be able to do 14 all by yourself. Okay, number 19. Remember the steps I take when dealing with dividing radicals. I put them together and see if they simplify. So if I put these together, you take your calculator, do 50 divided by 27, math, enter, enter. Well, it doesn't simplify. It's 50 over 27. So you leave it split apart. Now take my advice. Ready? Are you listening? Focus on this piece and simplify it. What does that piece simplify to be? 5 squared root of 2, correct? Now on bottom, focus on simplifying that. What do we get? 3 squared root of 3. So now you'd say, do 5 and 3 simplify? Nope. Okay, now we've now simplified it. Is my answer acceptable? We've got to rationalize the denominator. So we'll multiply by the square root of 3 over the square root of 3. So on top we have 5 square roots of 6. And on bottom, don't forget we have that 3. Then we have the square root of 9, which is 3. So on bottom we have a 9. 9 and 5 don't simplify, so we're done. You can't divide something that's under radical, something that's not. So hopefully you guys are seeing how easy this quiz actually was and able to see like, okay, now I can do that on the review very easily. Okay, awesome. I'm going to give you a little bit of time, not very long, to go through and do finish quiz corrections, put it in the basket for half your points back. The next question for you is, as a group, what I want you to do is look at problems on page 3. We're on page 3. Look at problems 19 through 27. I want you to look at those compared to problems 28 through 33. What I want you to do is on your whiteboard, one of you on your whiteboard be the scribe, and I want you to write down the things that are the same, things that are common between the problems, and the differences. Now look at the things that are in common in the original problem and the answers, and the differences in the original problem and answers. Does everybody get what they're doing? Comparing those groups of problems. What's different? What's the same? Ready, go. Okay, for the most part, it looks like some of us are done because we're not talking about math anymore, so you must be done. So, what are some things in common between those problems in sections 19 through 27 and section 28 through 33? What's the things that are in common? I hear square roots in all of them. What else? Parentheses, multiplication. Okay, what else? Yep, so we'll distribute on both of them. Good. I like all those things that are in common. Very good. Anything else? I just want to add in one thing. There's two terms being multiplied, correct? Okay, now let's talk about the answers that are, so let's talk about the differences. What is the difference in these? Yeah.
One was...
Good, so one of them are conjugates, and the others are not.
They're different problems.
Yeah, they're different problems. What do we notice about anything? What do you mean different numbers? What else do you notice about the answers between the problems, guys? So the first section has radicals in the answer, and the second group is all whole number answers. Okay, perfect. That is what I wanted you to realize. So I wanted you to realize that in the second group, notice they're conjugates. Remember that conjugates are the exact same term, just a change of sign in between. Now, if you multiply conjugates together, what you're going to get is a whole number out. Does everybody see how that's working? Okay, awesome. Okay, so everybody look at 28. And here's the rule. So when you have a pair of conjugates that are, this is only true if you're multiplying radicals that are binomial in form. Remember, binomial means there's two terms. So everybody look. Two terms being multiplied to two terms. Everybody good. What makes them conjugates? They're the exact same terms, just to change your sign only in between the two terms. Everybody see? So, when dealing with radicals that are binomial in form, to get rid of a radical, you're going to have to multiply by the conjugate. That's the rule. And then you'll get out a whole number, which that's what we're going to be wanting to do when we have radicals that are binomial in form in the bottom of a fraction. We'll rationalize the denominator by multiplying by the conjugate. So, I want you to look at the differences now between these two types of problems. And we're going to have a quiz at the end of the hour. So, rationalizing denominators correctly, so I don't want you to get confused. You only multiply by conjugates if there's two terms. So look at the difference. This is a one-term problem, and this is a one-term. Meaning, on bottom, you see how there's a radical? There's a radical on bottom. There's only one term. There's no plus or minus sign. Down here, there's only one term. You do not multiply by the conjugate to rationalize this. This one we would rationalize by multiplying by the square root of 3 over square root of 3, right? This one we would multiply by the square root of xy over the square root of xy, correct? Now over here, notice these have two terms, boom, boom, and there's a radical in bottom. That's a problem. So how we would rationalize this one is we would multiply by the conjugate, the square root of 3 plus the square root of 2. Isn't that the conjugate of that? So if you do it to the bottom, you do it to the top. Square root of 3 plus the square root of 2. And then we would distribute. We'll practice that in a minute. So once again, this has two terms, 1, 2. There's radicals, so the only way to undo the radical is to multiply by the conjugate, the square root of x minus the square root of y. You do it to the top, square root of x minus the square root of y. So does everybody understand how to rationalize the different problems? Okay, then let's go to 34. We're on the back page now. So 34, if I said to you simplify, you would say, okay, well, looks like all my radicals are simplified, correct? So then you'd say, that's my answer, but it's not an acceptable answer because there's a radical on bottom. Well, there's two terms, so I'm going to have to multiply by the conjugate. So let's all do that. Square root of 5 plus the square root of 2. If you do it to the bottom, you've got to do it to the top. Now, I can't stress this next part enough. If you ever have two terms, you need to put parentheses. Look right here. Two terms, so I need parentheses. Two terms, so I need parentheses. Now, this is what you're going to want to do, and you're going to want to have plenty of room to do work. So you're going to need some scratch paper for your stuff today. Just saying. I'll give you a second to get that out. So, everybody, if you can't focus in sections, this gets confusing. So watch. I'm literally going to distribute out the top. So what I'm going to do is I'm going to go like this. I'm going to show my work like this. I'm going to go, okay. So I'm going to focus on the top for a second only. I'm going to write top, just so I can keep my work organized. Let's distribute out the top correctly. We have two terms being multiplied to two terms. That's double distribution. 3 times square root of 5 is positive 3 square roots of 5. That's a total. How much you want to bet? No. I wish it was my mom. My mom's actually a high school teacher too, so she's teaching right now. Okay, so then we have 3 times positive square roots of 2 plus 3 square roots of 2. Now we've distributed 3 through. Negative square roots of 10 times positive square roots of 5. Are we all paying attention? Negative square root of 50, correct? Negative square roots of 10 times positive square roots of 2 is negative square roots of 20. Now you'd say, let's combine like terms. It doesn't look like there's any like terms, but I need to simplify this. Right? So, isn't this piece 5 minus 5 square roots of 2? Don't forget the minus. This is minus 2 square roots of 5. Okay, let's combine like terms. 3 square roots of 5 minus 2 square roots of 5 is how many square roots of 5? Yep, 1 square roots of 5. We don't need to write the 1. Now I'm crossing those out because we just combined those. 3 square roots of 2 minus 5 square roots of 2 is how many square roots of 2? Okay, perfect. That was all just the top. Now, we're going to distribute out the bottom. Here we go. Positive square root of 5 times positive square root of 5 is square root of 25, correct? Now the middle term will be plus the square root of 10 minus the square root of 10, which will be 0. So then negative square root of 2 times positive square root of 2 is negative square root of 4. So isn't that 5 minus 2? Yeah. 5 minus 2, which is 3. So there's my final answer. Do you see how that took care of the radical for me? Yep. That would be my final answer because there's nothing more we can do here. Our radicals are all simplified and everything's all good. So 5 minus 2 is 3. And that was on bottom. Does that make sense? Are we all good with that one? Yeah, because it was pretty quick because our middle term canceled out. Does that make sense? Yeah, good. Good question. Yeah. Okay, let's do another one. 35. Here we go. There is going to be a quiz on this at the end of the hour where you'll be allowed to work in groups, but you're going to want to know what you're doing. So, there's a radical in bottom. None of our radicals right now simplify. So we'd say to ourselves, well, that's my final answer. Oh, wait, no, we can't have radicals in the bottom of a fraction. So we'll multiply by the square root of 7 minus the square root of 2. So you got to do it to the top. Now, here's the one rule to remember. If you ever have two terms, you need parentheses. Oh, two terms need parentheses. Two terms need parentheses. How about I give you a second to see if you can distribute that through correctly? You can go for it. I need to go through it. So when you multiply out the top, you had 2 square roots of 7 minus 2 square roots of 2 plus square root of 14 times 7 minus square root of 14 times 2. So then 14 breaks down into 7 times 2. So will that be plus 7 square roots of 2? And then 14 breaks down into 7 times 2. So that'll be minus 2 square roots of 7. So you'll combine like terms. Were you guys getting there? So then, is that what you had on top? So 2 square roots of 7 minus 2 square roots of 7 is 0. Square roots of 7, so just 0. Negative 2 square roots of 2 plus 7 square roots of 2 is 5 square roots of 2, correct? And now on bottom, we have the square root of 49, our middle, then we'll have minus the square root of 14 plus the square root of 14 minus the square root of 4. So that's 7 minus 2, which is 5 on bottom. Our 5's divide out. Square root of 2. Most of you got it right. Questions? Okay. With 36, do we multiply by the conjugate?
No.
No, there's only one term. So we know how to do this one. What are we going to multiply by to rationalize? How many more x's do we need? X squared. So we'll multiply by the cube root of x squared. What's the one rule? Well, there's a million rules, but what's one of the rules? If there's two terms, you need to put parentheses, correct?
Yeah.
Okay, so now are we multiplying that to both of those things? Right? So 2 times the cube root of x squared is 2 cube roots of x squared, right? You can't actually multiply. You can just multiply them like that. And then the cube root of x squared times the cube root of x is positive cube roots. How many x's is that?
3.
X cubed. Now on bottom, we have the cube root of how many x's? X cubed. So you'd say, do any of those simplify? That piece doesn't. This piece is x, correct?
Yeah.
This piece is x. So we have 2 cube roots of x squared plus x all over x. Now I'm going to ask you a very important question. You got to think very hard before you answer. Is it appropriate at this point to then divide out those x's?
No.
No, you answered it right. I'm so proud. Very good. Isn't that connected with addition? So we know we can't just divide out across addition now. Awesome. A few weeks ago you would have said yes. You guys are awesome. Good. You're retaining knowledge. That's good. Okay, what I want you to do is finish up 37 through 44, then go hand it into the basket. 37 through 44. I need you to quick, fast, and in a hurry do those ones, and then go hand it into the basket.